Very good morning, students. Welcome back to the LABVIEW Programming tutorials. In today's session, as we understood the fundamentals of LABVIEW Programming in the previous discussion and how LABVIEW Programming is different than the other programming languages or conventional programming languages or high-level programming languages like C, C, Java, Python. And we understood LABVIEW programming language is basically a graphical programming language, right? So in this particular session, today we'll enter into actual syllabus provided by VTU, and we take up the first experiment and how to build the VI through the LABVIEW tool we're going to explore. Fine. So as I said, the LABVIEW experiments are listed as follows. For any understanding of any tools, things goes from simplest experiment called as arithmetic operations, logical operations, then we enter into a kind of loop concepts, then we call the functions. Then we could able to do the demonstration experiment from experiment 9 onwards. So through this understanding of this course completely by doing all these 12 experiments listed here, you will be able to demonstrate the use of LABVIEW front panel controls and the indicators, and how to implement the Boolean different operations, loops and arrays in the LABVIEW, and you could able to develop arithmetic and mathematical functions using the LABVIEW. And you can design small VIs like calculators, data acquisition and signal processing through the LABVIEW. Okay, once again welcome you all to this experiment 1 tutorial, basic arithmetic operations. So now I'll directly launch the tool. So once you launch the tool, you could able to find the two different parts, create project and open existing. If any existing projects are done with the tool, and it will be listed here, and you can create a new project from here. Okay, so we'll start with the blank VI, saying that it is meant for just experiment sake. Okay, once we familiarize with the tool, how to create the project and how to link the VI files to the modular programming, we're going to understand. Okay, so now I'll go to file, take new VI, which will pop up two windows, right? So if you say Control T, they will be aligned vertically to your window so that you can view them simultaneously and you can start to programming on them, right? So now we are doing the first experiment, say experiment number 1. Basic arithmetic operation. Basic arithmetic operation. Right. So as I said, in order to understand the basic arithmetic operation, you need data types. So, right. So we'll go with the fundamental data type called as numeric. We take two numbers. Okay, so right click on the front panel, and one more thing need to be remembered here is in the front panel you will get all the controls and indicators, and in the black diagram you will get different functions that need to be done logically, correct? So go to the front panel, take two numbers, go to numeric and take numeric control, name it as X. And similarly, I'll take one more numeric control. I'll name it as Y. Okay. So once you say arithmetic operation, you could be able to remember 4 fundamental operations, right? So, and those 4 need to be stored at the indicators or the outputs, right? So now go to front panel and take the numeric indicator. Okay. So once you call the controls or indicators, automatically they'll appear in the black diagram. That what you need to be observed whenever you call the any controls and indicators. let me call it as sum. Similarly, I'll call one more numeric indicator in order to store the difference result, difference. Similarly, one more for storing the product, and similarly one more to store the division operation result. Okay, so see here, all your controls and indicators are being exported here for the block diagram panel. Now the things we left with only calling the logical operations are the logical functions that you want to use by dragging them from the function palette. Okay, so now I'll take up the functions from the block diagram, right click on the function palette. So now go to numeric container, take the add the function block, place it. So once you place any function block, please do mention the label of it so that it will be comfortable, and whenever you read it back you can able to understand them very well. Okay, so go back to the numeric palette again, take subtract, place in between them, then go to numeric, take multiply, then similarly you go to numeric and take divide. And you can observe that by exploring the numeric container you can get several operations like this. Okay, so in order to understand at the beginning stage we go with the fundamental operations. Later, once we come on to the additional task or self-learning assignments, then we could be able to make use of all the functions come under numeric palette. Okay, so now the thing is need to be wired. The beautiful advantage of LabVIEW tool is whenever you go near the control or indicator, automatically the winding will going to be enabled. You just need to start, click, then wire them. Then similarly I'll go to connect another input to the adder. Then similarly I'll connect subtractor to inputs and multiplier to those inputs. Wherever node has been created, that line is connected, and if the node has been jumped or crossed, then it means that it is not connected. Yeah, so now I'll connect the output of all the functions to the indicators. Okay, so label all of them. Hope you will be able to see, right? So now look at the toolbar of the front panel and the block diagram. The first three options are run continuously, abort execution, and pause the execution, and highlight the execution. And there are so many different operations are there, one by one when we enter into a complex kind of program concepts. At that time we can make use of them. Okay, so for this experiment's sake, let us give the inputs. And one of the biggest advantage of the LabVIEW is during the runtime you can change the data. Okay, so I'll just move to run continuously mode. Then I'll change my inputs to X as 25 and Y as 5. Look at all the output indicators are being processed. Okay, if you want to look at the value how they pass on the wires, you can make use of the highlight execution, and you can see what kind of values are passing over the wires, each wire every time. Since we are in continuous mode, every time it will going to reach the indicator. Whatever the data, if you want to change, you can change now also. See, look at like this. You can also change, and once it reaches the indicator, automatically the updated data will be stored in the output indicator. So this is how we're going to conduct the first experiment. Okay, so I advise don't be stick on with the only 4 fundamental arithmetic operation. You explore the function palette of numeric and then do exercise on other functions as well. Okay, and if you want to know about the any functions that if you don't know, okay, then you can make use of the tool by selecting the icon and say help, which will going to tell you what that function, divide function will be there and what is the owning palette of it, what is the requirement, how it to operate, and even with examples are available. Okay, I want you to study this if the logical functions are any functional icons that if you are been selecting from the LabVIEW if you are not aware. Okay, so you can thereby you can be able to increase your ability towards the self-learning. Okay, so with this we conclude for this session to understand the basic arithmetic operations. Thank you.